I want to welcome you to this presentation on severe weather in Arizona. My name is Aubrey, and I'm an adult services librarian with the Chandler Public Library. And today we have Dr. Erinanne Saffell, the Assistant State Climatologist for Arizona. So, I mean, what better person to be here to share her knowledge on extreme weather, especially in Maricopa County. So, I want to thank you, Dr. Saffell, for being here. And if you visit our website at chandlerlibrary.org, you'll be able to see other programs that we're doing in the future, mostly online right now. But, we definitely have a lot of really great things coming up. You can also subscribe to our online newsletter so that you can receive information about upcoming events, new book releases, and all that good stuff. If you have any questions after the presentation, you can email me at Aubrey, aubrey.cowitt, Kowitt, at chandleraz.gov. So I will go ahead and let Dr. Erinanne Saffell take over, and we're all set.
Thanks, Aubrey. I really appreciate it. Thank you for the introduction. Yes, I am the Assistant State Climatologist here in Arizona. I've been born and raised here in Arizona. This is my state, and I'm just thrilled to be here to talk to you about severe weather. The reason why I'm so passionate about severe weather is I remember my family having to sandbag our house when I was about 3 years old because of a flooding event. So that really triggered me. And then I remember my mom driving our station wagon when we were all very young and we were in the back, and she was terrified driving through this torrential rain. These are the things that when you talk to a meteorologist or a climatologist, something usually in their formative years triggered them to be more engaged and interested in weather. And that's absolutely the case with me. I'm fascinated with severe weather. My goal is to educate people so that everyone understands these things that are happening around them. And so we'll go ahead and get started and talk about some of the severe weather in Arizona. Now, when I was young and going to school as an undergrad, I had to take a class as part of my program. And I'm looking at the class. It was Intro Physical Geography, GPH 111 at ASU. And I'm looking at the class going, I don't understand geography. Why am I taking a class in geography if I want to study weather? And that class changed my life. It explained so much of what I already kind of understood. It explained the science behind these processes, and it also explained the patterns. And that's what geographers do. We find patterns across space, and we try and solve these problems and explain these problems so we can keep people safe. Geographers inherently do those applied kinds of science of opportunities. And so we look at maps. Geographers look at maps to help us find those patterns across space. And so we look at a map here, and we can see that there were a lot of tornado watches in Mississippi in 2011, one of the largest outbreaks of tornadoes that we had in our recent record. And you can see where it's highlighted and where most of those folks who were at risk were found. And you can also see that in Arizona, we don't tend to have as many tornado watches, right? It's not something that we grow up with here. Here's something that I teach in class. I teach classes in extreme weather. And in order to understand extreme weather, you kind of have to understand a little bit about how clouds form and how temperatures change. And so this is something that I talk about in class. And I went outside, and this is me, that's my hand right there. And I'm using a handheld instrument called an infrared thermometer that you can buy at Costco or at Home Depot or Lowe's. And what it'll do is it'll measure surface temperatures. So you can, those things that we've been measuring, that you walk in somewhere and they're measuring your temperature on your head. That's what we're doing, is we're measuring the infrared temperature, because that's a way that surfaces, that's how we measure surface temperatures. And so I went out and I measured the same time in the same place. I was just like within 10 feet of all of these temperatures. So I went out to the parking lot. You can see the surface temperature there was really hot. And then I went to, I was in the sun and still on the pavement. So I was on the cement sidewalk and it wasn't as hot, but it's still hot. Then I went into the shade and you can see that it was much cooler. So the surface conditions that we're dealing with that we build so we can have a nice blacktop asphalt and a safe place to park our cars and cement sidewalks so we have safe places to walk. Those impact the temperatures around us. And the color of those surfaces really plays a role. So you would never walk barefoot on a blacktop asphalt in the middle of summer. You would burn your feet because dark surfaces absorb the sunlight and make it hotter. But lighter colored surfaces reflect the sunlight and don't get as hot. And so that's where, when you look around our community, you'll see these different colors, but you'll also see us play out and put it into an actual application. So you'll look at our citrus trees that we have all over the place, and you'll see that a lot of those trunks are painted white. And we paint those trunks white because we kind of trim off the citrus tree to make it nice to look at. A citrus tree most often is going to grow naturally and have the branches come around the trunk and kind of protect the trunk, because a citrus tree can actually get sunburned. And so we paint the trunks white so that it reflects the sunlight. So we're doing those kinds of applications of how that sunlight impacts our surfaces and how it plays a role. I have this picture of this menacing dude with that eye grease under his eye, and you'll see people that work outside, or not work outside necessarily, but play outside. You'll see them put that eye grease under their eyes, and it's the same kind of process. So the sunlight comes down and it's absorbed by darker colors, and it'll be absorbed there so it won't bounce up and get in their eye, and they'll be able to catch the ball. So those are really, really neat kind of applications that we talk about in geography. And we talk about things like this in geography. So the lightning numbers, who remembers how many storms we had in the summertime last year? Not very many. And so we didn't have very many lightning strikes. And so we can look at that and we can measure how many lightning strikes occurred during our monsoon season here in Arizona. And in 2019, we had very few. In 2020, we had very few. So if we're not having thunderstorms, then we're not having lightning strikes. A thunderstorm inherently means that lightning is occurring. So we look at those kinds of things. And then, did we get hurricanes in Arizona? Well, in 1972, that's what I remember my mom driving through, Hurricane Joanne. It was the remnants, and it was just a deluge. And you may remember in 2014, we had Hurricane Norbert. Now, for us in Arizona, it's not that we get the impacts like you would see in Florida or along the Gulf Coast. Instead, we get rain that comes in. And so we get the tremendous amounts of precipitation and flooding potential. So why does that happen? It all has to do with the global winds. So here in Arizona, and let me just change my cursor here so you can see it a little bit. Pointer options. I'm going to go with my laser pointer so everybody can see it. And so right here's Arizona, right in through there. And the winds that we get in Arizona typically come from the west. We have westerly winds. We name our winds the direction that they're coming from because we're really interested in understanding what they're bringing. So the winds come across the Pacific, boom, like that. So we tend to have the winds that come in kind of dry out, that hit us in Arizona. They kind of dry out because they go over some mountain ranges. Down here, we're having winds that move in this direction, kind of over toward Hawaii. And so that kind of drives the hurricanes away from Arizona. We don't tend to get them to come into Arizona. So we don't have as many hurricane impacts here in Arizona as you would over here in Florida, because all of those Atlantic basin hurricanes just boom, pop right in. It's from the global winds. All right, let's see if I can go to the next There we go. So when you consider what is the largest natural hazard in Arizona, I get that asked quite a bit. And there are different ways to answer that question. Obviously, right now we're having a really strong wildland fire season. We did last year. When we have the fuel for these wildland fires and we don't have any precipitation kind of tamping down those fires, then we're going to have the potential for a greater wildland fire season, and that's unfortunate. So right now, that may be one of our largest hazards at this particular moment. But when you consider the potential for flooding that we have in Arizona, that can be kind of frightening. Here in Maricopa County, you're driving around and you'll see things that you may not recognize, but they're earthen dams. There are about 30 earthen dams in and around Maricopa County that are designed to keep us safe from water. You'll see these retention basins in your neighborhood, and we call them parks. They dig down. Those are designed for flood control. So flooding is a huge potential problem. But then when you look at the numbers of people that are succumbing to our natural hazards, right now that appears to be heat. We had over 300 fatalities in Arizona from heat last year. That was one of our hottest years on record. And we're about to hit right now. We're at the start of our first heat warning. It's an extreme heat warning, so people are at risk from heat. So it's hard to say what the deadliest hazard is in Arizona. We have the potential for a lot of different hazards. They just don't propagate as often as you might see earthquakes in California or hurricanes in Florida, but we still have the potential for other kinds of hazards. I wanted to show you this from a friend of mine, Mike Obinski. He's a local storm chaser, a local photographer, and I'm going to just play a little bit so you can kind of see the context of what we're going to be talking about. And it's an amazing kind of experience to watch his time lapses. I've seen things in the atmosphere from these time lapses that I've never seen just with my eyes. So it's giving us kind of the idea of what we're going to be talking about here. Right? So looks familiar, doesn't it? So those are some of the things that we experience in our summer monsoon season. So I'm going to go to the next slide. Hopefully I can do that. And maybe not. And pointer option, and go back to my arrow and pointer option. Don't you all love how we have to manage these things? Automatic. And let's see, one moment. There it goes. I did it. Thanks for waiting for me to handle the technology. So what we're going to talk about largely in our severe weather discussion are thunderstorms and the impacts from thunderstorms. I also threw in a little bit about tornadoes, although we don't get those extreme tornadoes that you would see on the Great Plains. We're not as susceptible to those large types of tornadoes. I threw those in for a discussion. I also threw in a little bit about hurricanes, so if we can get to it, we may discuss that as well. But thunderstorms are where we experience a lot, and we will have certain impacts that we need to be aware of and we need to prepare for. These are our warm season events typically, but you can have thunderstorms happen any time of the year, but they tend to happen and propagate more often in our summer monsoon season. So we'll take a look at some of the distinctions there. I do want to give you some words. So this is going to run. I'm going to just let this run right here. And it's going to give you kind of an understanding of a watch versus warning. And these are terms that are triggered by the National Weather Service. So they're issued by the National Weather Service. And there are certain kinds of things that you're supposed to do as a result. So we have tornado watches, tornado warnings. We have flash flood watches, flash flood warnings. And those are meant to make you aware and trigger certain behaviors. we typically have severe thunderstorm watches warning. And what that means is that we can expect hail of about an inch in diameter or larger, or extreme wind. So those are things that we want to pay attention to more often. Typically, we won't get tornado watches warnings, especially down here in the area, although we've had some. So I definitely wanted to bring that to your attention. The National Weather Service, when you're looking at official watches and warnings, a watch means that you need to pay attention, something may happen, and a warning means imminent or occurring. It's happening right now. Do something to make yourself safe, and hopefully that watch has given you information about what you're supposed to do. So, if we were in the Great Plains, a tornado warning means you get as much between you and the tornado. You protect your head. If it's a flood, a tornado or a flood warning, that means you get up and away from the water. So there's all sorts of different behaviors. And so it's important to prepare yourself. And I'm glad that you're watching this with me so that we can start getting you prepared for some of these extreme events. Why does that? And pointer options, highlight. I'm just going to go highlight. There we go. Thanks for waiting for me. Okay, so what's a thunderstorm? A thunderstorm is a pretty intense kind of system, but it's a really short-lived system, believe it or not. So we're looking here at a picture that's called a single cell thunderstorm. So it's like one big cloud, and that's how we think about these thunderstorms. That's what we look at. So a single cell thunderstorm, we're going to have warm air that rises and cold air that comes down. So that's the whole process of a thunderstorm. And the reason why thunderstorms happen is because having warm air rise means that it's an unstable atmosphere. You may have heard that if you watch some of the movies that we have out there on severe weather. They're like, it's unstable, it's unstable. What that means is that the air can rise, which means if you can get air to rise, then it gets up high enough, it'll cool off. Like when we drive to Flagstaff, it gets colder as you get to 7,000 feet. So we get warm air rising and cooling off. And then if it cools off, it can cool to the dew point temperature, which means it can make a cloud. And so that means you might have precipitation, you might have rain that comes out. So that's what we're paying attention to. So warm air rises, cools, and then cold air is going to come back down. You may have experienced this. So here comes a big thunderstorm, big, huge rain event, and then you walk outside 45 minutes later and it's cleared away, but it's cooler. It can be 20 degrees cooler because that cold air comes down from that thunderstorm. And it feels great. And you're like, wow, this is awesome. And what that does is it stabilizes the atmosphere. It kind of kills the clouds because these clouds are made with warm air rising. So when you bring that cold air down to the surface and it cools us all off around it, that kills the thunderstorm. So usually that's done in about an hour when you're dealing with one cell. And so you can see the life cycle of these thunderstorms. When they're starting to grow, you just stand there and you can watch it and you watch those clouds go poof, poof, poof. Those are cumulus clouds. So the cumulus growth is where it starts. And then it starts to mature so that the clouds grow the precipitation droplets inside. So you have little tiny cloud droplets, and those little tiny cloud droplets have to get big, 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 big enough so they start falling under the force of gravity as a raindrop. And so once that happens, once we get those cloud droplets big, 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 they'll drop down as precipitation. That happens during the mature stage. And then when you see kind of like the top of the cloud kind of shearing off, we call that an anvil. And that's because the updrafts are no longer in charge of that storm system. Instead, the winds at the upper levels are kind of shearing off the top. And that's the end of the life cycle of that thunderstorm. Again, 45 minutes to an hour, this one cell will be done. It'll be finished. It'll be cut off from its power supply, essentially. So we have those kinds of things that we pay attention to. And then we kind of look at three different types of thunderstorms. So the single cell is what I just described. And you may have seen that happen out in the desert. You just see this huge cloud and it dumps and then it's done. That's a single cell. What you'll see happen in the summer is we'll get kind of more than one of these cells building up. So you can have a single cell here and it has the downdrafts that come down and it can trigger off another single cell, and these line up next to each other. So we call these multicellular systems. Now, when we're dealing with multicellular systems, which will happen, you look out and you see all these clouds, those can absolutely last longer than an hour. And then what you're dealing with are more places that can be impacted. So a single cell thunderstorm really is only impacting a small area in a very short period of time. So there usually isn't much risk associated with a single cell. But when you start to build these up, then you definitely have more risk. So there's more water that can come out. There's more impact to more people. And think about the things that happen with a thunderstorm. You have that water coming down, precipitation, and if you have a whole bunch of it, you have the potential for flash flooding. You have lightning, you can have hail. So all of these are associated with thunderstorms. And then there's the big daddy over here, the supercell, which we tend not to have too many of in Arizona, but it's fascinating to see. So I'm going to go to the next slide so we can watch a video that my friend Mike recorded in Texas. So we're going to watch this supercell, and I just want to bring this to your attention. It's fascinating. So Texas, Great Plains, so Oklahoma, Nebraska, Kansas, you'll see these things triggering. So the thing about a supercell is there's rotation. So can you see that rotation? How it's going round and round and round? That's what makes it a supercell. And with that rotation, that means that the potential's there for something rotating coming out of it. So perhaps a tornado. And about 10% of all supercells trigger and form a tornado. And they'll usually happen kind of over on this side. So watch over here, and you'll see kind of that downward movement and the swirling of the dust underneath. That's the location where you may have a tornado form. No tornado form from the supercell, but it's fascinating to watch and see, isn't it? It's amazing. Look at that. So that what you're seeing down here, the lowering of the base of the supercell, that's called a wall cloud. And so that's another trigger that there may be a tornado. Again, Arizona, not necessarily one of our issues, but really fascinating to see. And we're not all going to stay in Arizona our lives. We may go into other states that have more likelihood of having supercells. So I did want to talk to you about the types of winds that happen from thunderstorms. So you have warm air that rises and you have cold air that comes down. And that cold air that comes down can move out ahead of the storm. And we call the winds that are associated with thunderstorms, we call them straight line, which distinguishes them from winds that are going to be moving in a circle from a tornado, right? So straight line winds can still be as dangerous as you would have with a tornado. So you can still have very fast winds. 60 to 70 mile per hour winds can do this kind of damage. And you can see that that is potentially harmful to people, right? You don't want to be in those kinds of structures when you get these kinds of winds. So then you look at straight line winds that are about 70 to 80 mile per hour winds. When we start looking at things like this, we're starting to move into like an EF0 tornado type wind or a hurricane type wind. So we measure our types of systems, and we want to understand the risk. And the risk comes from how fast the winds are going. So straight line winds are dangerous. So now we're popping up to about, an EF0, trying to get into an EF1 tornado or into a hurricane type of event. And you can see the type of damage that happens there. And now we're going 90 plus. And so now we're definitely into the speed of tornadoes. But again, they're just straight line. They're just coming from a thunderstorm. And look at the kind of damage that you can have here. Those straight line winds can blow hail sideways into your house And the pitting that happened here at the Starbucks down there, you can see that kind of damage. So definitely it's something to pay attention to. Now, so let's talk about the winds. We have warm air rising in a thunderstorm. The cold air comes down. We call that a downdraft, that cold air that comes down. And that cold air can come down pretty substantially. And those downdrafts can be pretty intense. And the downdraft, that cold air can come down and it hits the ground and there's nowhere else to go except straight out in front of the storm. So that cold air comes down, hits the ground, and moves out ahead of the storm. And we call those gust fronts. And we can see those on radar. So if you're interested in getting an app on your phone, you can look at a lot of different really cool apps that are free that show you the radar. And once you train your eye, you'll be able to see these kinds of things. But right in through here, that's the outflow boundary. And we call it a gust front. And that's where when you're here in Arizona, you may have that gust front pick up dust and create what's called a haboob. So a haboob is a very specific type of dust storm. It's generated by the downdrafts of that thunderstorm, that downdraft moving out ahead, picking up dust. And so this likely will be a problem that we have here if we get some thunderstorms building up in the summer. It would likely be a problem for some of our early thunderstorms. So let's watch this video. This is again Mike Obinski. I've got a couple of good storm chaser friends and they do amazing work. Mike's one of them. And I encourage you to look up his work. You can see all sorts of neat things, but let's watch this haboob. This made international news. All right, so what we're seeing, it's coming up from Tucson and that dust is just being pushed by the storm system. And here it comes. It was so tall. We had so many of these very extreme dust storms, haboobs that year. I'm going to stop it right there. So much so the next day, the sky was just so hazy. You could see that dust just hanging in the air because we didn't have a storm. Usually after a dust storm, we'll have the rain coming after it, and that'll clear out the sky. If you've ever noticed how clear, how blue the sky looks after a storm, it's because it's clearing out all of the particulate, all of the dust in the atmosphere. And so that drops down and it clears out the sky. And that didn't happen that year. So we had some amazing kinds of really high particulate, high dusty days after those dust storms. And then this happened. Let's watch this.
It is in the art of marriage that the little things are the big things. It's never being too old to hold hands.
Okay, did you hear that?
You listening?
Yeah. So that's thunder, which means there's lightning. And then here comes the wind and her poor veil. And then they're aware that something's going on, but they have to finish, right?
You have today.
You were trying to get married here.
Excuse me.
And the pastor keeps going.
Jennifer and Gustavo today will join separate lives together.
Lightning.
The two separate bottles of sand symbolize your separate lives, separate families, and separate sets of friends.
Plus they're breathing.
They represent all that you are and all that you will ever be as individuals. They also represent your lives before today as these two containers of sand are poured into the third container.
Hopefully the wind didn't
just as these grains of sand can never be separated, poured again into the individual containers, so will your marriage be.
Oh no, oh no. Now think to yourself, what would you do? These are important considerations. Would you already know what to do ahead of time? Would you plan? Is there a way to know that there was a storm coming before the wedding? And maybe
okay.
Look at it, it's so dusty. So that's the haboob that's coming through. That's the dust storm.
By the authority vested in me in the state of Arizona, I now pronounce you husband and wife. Congratulations, you may kiss the bride.
They did it. They made it, and everybody was okay. But wow, something to consider ahead of time, right? So these are things that we need to know that are possible in our community. So I'll pass you through. Something else that can happen with our thunderstorms. I'm sure you're familiar with this term. It's been something that we talk about, microburst, which is really all it is a really strong downburst. So it's that the wind coming down, but it can cause damage. And that big ball of rain right in through there, you can sometimes see these microbursts. I'm not sure if you're familiar with our bubble dome that we have at ASU. That's actually our second bubble dome. We built one and then it was destroyed by a microburst in 2008, so we had to build another one. So absolutely, these things can cause a lot of damage. Here's a video that we're going to watch. Brian Snyder is another friend of mine, and he does amazing work, kind of like with Mike Obinski. We kind of all of the storm chasers in Arizona, we all kind of know each other and interact with each other. And there's just some amazing things to see. So we're going to watch this. This is over Tucson. See it? And we'll let them give us a little bit.
Photographer and monsoon chaser Brian Snyder was taking time-lapse footage of a storm in the Tucson area when he captured this incredible weather event, a wet microburst.
Oh.
Microbursts affect an area of no more than 2.5 miles across, and they occur when a cooled, heavier column of air sinks rapidly in the middle of a thunderstorm. As the air hits the ground, it spreads out with great force, often generating winds of over 150 miles per hour. In the case of a wet microburst, it also brings crashing rain, often described as a rain bomb.
Yep, and that's kind of what we talk about. So we have this bomb of cold air that just comes crashing down. It doesn't last long, it's just a few seconds, but you may see the wind shift abruptly if you're watching the wind and it's going like this in the storm and you're inside your vehicle or your house, and then all of a sudden the wind shifts abruptly for a little bit. It's more than likely it's a microburst. So absolutely some issues to pay attention to and be aware of. We'll shut down Sky Harbor if we think this is going to happen, because it can be dangerous for flights. So we don't want to have any of our airplanes take off or land when the potential for microbursts is there. And so you'll see that it will happen sometimes in the summer. I do have one caveat. Brian Snyder is not a monsoon chaser, because a monsoon is a season. So that's when we have more thunderstorms. Brian is a thunderstorm chaser. He's a storm chaser. So that distinction of what is a monsoon and what is a thunderstorm, it's kind of interesting, right? Those are two different things. All right. So what else happens with a thunderstorm? When you hear thunder, that means lightning is happening. You may or may not see it. You may or may not hear it. But lightning will be happening in a thunderstorm. So lightning happens inside the tall cumulus clouds, and we need to get our clouds tall enough so that they get so high that they're dealing with ice crystals inside the cloud. So even in the summertime in Arizona, the very tall levels of our clouds, you can see they can grow so tall in the summer. There are going to be ice crystals way up high because they're so high up in the atmosphere. They're 30,000 feet above us, 20,000 feet above us. You're going to have ice crystals in the cloud itself. So absolutely, those ice crystals then, what they do is they hit some of our raindrops and they shear off some of the electrons. Boom, boom, boom. And so what that does is it separates charges. It's the same thing that happens in the winter time. If you've ever walked on your carpet, you walk on your carpet and then you go touch your refrigerator or your doorknob and you get shocked. It's the same thing. You're separating charges. When you comb your hair in the wintertime and your hair starts flying up, It's the same thing. That's the same thing happening inside a cloud, except in a cloud, it's going to have a bigger impact. Absolutely. So you can have the lightning, and then it'll trigger thunder as a result. Lightning, what that does, it's a huge electrical charge through the atmosphere. It's not very big, not wide. It's like maybe an inch in diameter. And of course, it's very, very fast. But what it does, it's also very hot. It's hotter than the surface of the sun. It moves through the atmosphere, which heats up the atmosphere, which causes it to expand. It's like when we heat things up, they are going to expand. And so as that lightning strike moves through, it expands the atmosphere instantaneously. And then once that lightning strike is done, which is speed of light, the atmosphere will come crashing back together, and that's the thunder. So that's the speed of sound that we're hearing. And so when we're trying to figure out how far that lightning strike was from us, we have the speed of light, that's the lightning bolt. We have the speed of sound, which is the thunder, because that's the sound that's emanating from that atmosphere coming together. And so when we look at that, we usually have that 5-second rule where we look at the lightning and we start counting 1 Mississippi, 2 Mississippi, 3 Mississippi, 4. Every 5 seconds that we count equates to a mile. So if you're looking at that and you count to 5 seconds and then you hear the thunder, that means that the lightning bolt is a mile away. You are at risk. You are absolutely at risk. We've had people struck by lightning that the lightning was 10 miles away from them. The storm was 10 miles away. So my rule that I always teach my students is, if you can see lightning, you need to seek shelter. You need to get inside so you can be saved. So that's always the case. You don't want to put yourself at risk. Here in...
Hey, Erin.
Yes.
Oh, sorry to interrupt. I think Isabella has a question.
Oh, please ask, Isabel. Can you unmute?
It's not a question, but I need to leave because I have my dance class. Thank you for teaching. Bye. I need to leave.
I'm so glad to see you, Isabella. Thank you. Bye. Bye. I hope to see you in high school and college. Thanks. All right. And so what's really cool is when we're looking at where lightning happens, more lightning strikes in the United States happen in Florida. It's considered to be lightning alley. So there's a greater level of risk in Florida. However, in Arizona, our lightning strikes are just spectacular because our storms usually happen high enough, the clouds are up higher in the atmosphere, so we can actually see that lightning come down. So we have a lot of lightning photographers here in Arizona. So spectacular to look at. And of course, the background and the setting with our cactus and our mountains. Who can't get better lightning pictures than us in Arizona? There are people that die every year from lightning in the United States. On average, we're about 2 or 3 fatalities in Arizona every year from lightning. And it tends to be kind of up in the mountains and the mountainous area in the summertime. People may be hiking and they are far away and here comes a thunderstorm and there's no place for them to go. So they may be at risk. So it's really important to pay attention to your surroundings. It's not that the lightning strike will strike you directly. Most people are not struck by lightning directly. They're struck indirectly, side flash or a ground current, because think about what's going on. You have a thunderstorm, you have rain usually. So you have rain, you have a wet surface, and now you have an electrical current that's coming down from the sky and hits that wet ground, and it can move across the surface. So it's important to recognize that level of risk. Although most people aren't struck directly by lightning, you are still as much at risk from one of those ground currents or a side flash. Absolutely. And injuries are usually going to happen outside. Well, we won't watch this video, but this was from someone who was practicing for soccer I think it was in Russia a couple of years ago, and you can see a spectacular lightning strike. Fortunately, he lived. Most people do live from if they're struck by lightning, but it's kind of like having one of those big defibrillators on you. And so it kind of can impact your electrical system. It can stop you from breathing. It can affect your nervous system. And if you're wearing any metal, that electrical current on you, it's very hot, it can melt any metal that you might be wearing. So there are a lot of other injuries that can happen from lightning. You don't want to do it. Don't want to get stuck. Even though you'll probably live, you don't want to get struck by lightning. Not something you want to do. So the way that you stay safe from lightning is you stay indoors. It's been since the 1950s, I think, that the United States has had no fatalities if you were inside your house structure, closed structure, or even in your car. And when I say a car, I mean something that has a steel frame that you can roll up the windows, and you're not going to be touching the outside area. That's usually a safe place to be. So if you're hiking and you're like, oh my gosh, here comes a thunderstorm, you want to get into your car as quickly as possible, as long as it has that steel frame. If it has one of those soft tops, maybe go with a friend who has a steel frame vehicle. So get inside. That's going to be the safest thing that you possibly can. Now, if that's not the case, you know, you want to get as low as you can, but you don't want to lay on the ground. These lightning strikes are really loud. You may have heard one, you may have been that close, and you know, they can burst eardrums. So there are a lot of things going on with lightning. Oh, so these folks there in the middle with their hair standing up on end, they were struck by lightning. They lived shortly after they took these pictures. They thought it was funny looking at their hair. So that's a clue that lightning may be striking very, very soon. So this one, let's see if I can go back. Let's see if we can get this. Oh, so the grounding. When we talk about the grounding that happens, your car isn't grounded. It's kind of a Faraday cage that you're dealing with. The lightning, the electrical current will move around your steel frame and then dissipate down to the ground. And that's essentially what grounding is doing. It's discharging into the ground. And so, you know, lightning rods do that same kind of situation, do that same kind of thing. This is what I wanted to show you. So typically in our fleet, our commercial fleet of airplanes, typically they're struck once a year. And they're fine because they've restructured our commercial fleet so you can have a plane struck by lightning, and it's the same kind of thing that would happen with your car. The lightning would dissipate and move away. They will land the plane very, very quickly as soon as they possibly can, because the electrical current can disrupt the electrical supply. So they will land the plane very, very quickly. But typically everyone is safe if you're struck inside an airplane struck by lightning. You won't get harmed typically. It'll move around the outside of the plane. So you're fine, usually. What other things happen with thunderstorms? We can get hail. And in Arizona, our hailstones aren't usually that big. The largest ones we have are about 3 inches in diameter. The largest hailstone that was ever measured in the United States was 8 inches in diameter. So that's a consideration. You want to pay attention to those kinds of things. The way that we get hail forming is we want to have thunderstorms that can grow very, very tall. So they can go up to that high portion where they're very, very cold, so they can freeze. And so we've got updrafts and downdrafts that happen inside a thunderstorm. And so you'll take a little, what's called a hail embryo, that little kind of frozen crystal, and it can start moving up to the high portions of the cloud, and it'll get coated with ice. and then it might move down a little bit, melt a little bit, and then it goes back up inside the cloud and grows bigger and bigger and bigger. So depending upon how strong that storm system is and how strong those updrafts are in holding that hailstone up in the cloud, it can grow bigger, bigger, bigger. So absolutely, that's a consideration. Now, we talk about the size of our hailstones coming down, and so 3 inches, a teacup, I don't know. I think they need to update some of the terms, but I put this on our slide so you can see how fast the updrafts need to be to hold that hailstone in place. So the hailstone here that was 8 inches in diameter, that had to have at least 160 mile per hour updrafts, holding that big hailstone up in the cloud, getting bigger, bigger, bigger. So that's really fascinating to think about. And then ultimately gravity is going to win, and that hailstone is going to come down. And if it comes down over your property, then you might have consequences. The last person that died from a hail event in the United States was in 2000. A 4-inch, so grapefruit size hailstone hit a 17-year-old on the head in Fort Worth. It was during a tornado, an EF3 tornado event. So that was the last time someone's died from a hail event in the United States. It's very rare because usually we can go somewhere and get out of that hail event. And hailstorms are very short-lived, especially here in Arizona. They're not big and they're short-lived. So we'll watch here again. We've got Mike. He went somewhere else, not Arizona. And I'm going to pop up and I'm going to go right here. I want you to see this. So kind of look over here. See that white portion coming down out of the cloud? That's hail. So that's usually...
Dude, I think there's a new hail dump right here in front of us.
Usually you'll be able to see if hail...
Freaking losing my mind right now. Look at this, double hail cores coming down.
So that's really kind of cool to understand that. When we see precipitation, it's usually we call them fall streaks. They're usually darker in color against the sky. And so that's typically precipitation. So if you see this white stuff coming down, that's typically hail. And for us here in Arizona, maybe a minute. It's usually not very long-lived. It can be longer-lived out in the Great Plains. But Arizona, in Maricopa County specifically, we've had the costliest hail event in the United States, almost $3 billion of damage that happened in 2010. So we had a storm system that moved through about 3 days worth of a storm system. It went up to Flagstaff. It generated tornadoes up in Flagstaff that caused damage. But down here in the Maricopa area, here's the damage it does. So we'll watch this.
Going out here to take a look at the damage. All the cars have been pelted completely here at Coulter Nissan. You can see the dimples all up and down the cars. And then check this out. The windows completely busted out of that brand new Versa, completely pelted with all kinds of hail damage up and down. Check this out. Brand new cars.
So this is not an unusual situation in Arizona, Colorado as well. I mean, you're going to have these hail events that are going to hit the places where we've got cars for sale. And what they'll do is, I mean, the car's structure will be dimpled and you'll see it on the car, and they'll replace the windows, and then you can have a hail sale and go buy one of these vehicles. That's what'll typically happen. I do want to show you this for this event. So this is where we had kind of up in the Cave Creek area, 3-inch diameter hail. It's going to get loud. I want you to see what it looks like when we have one of our dumpings. This is the same. so it doesn't last long, right? But you can see the damage. It was bringing down some branches, and other damage happened as a result. It hits your house, so you can have roof damage. It hits your air conditioner unit, so you have air conditioner damage. So yeah, there are consequences when we have these large hail, well, for us, these hail events. Absolutely. All right. I'm gonna just have this one last slide here where we look at other considerations. It's important to understand that with our thunderstorms, we can have intense, heavy precipitation, and it's going to hit the ground. And we're susceptible to flash floods here in Arizona. And that's because we have very clayey kinds of soils. We have very hardened soils. And we also live in cities that just have, asphalt and concrete on the ground. So we're susceptible to flash flooding as well. I'm going to go ahead and leave this for maybe our next event that we can talk about. I can talk about floods for hours, and I absolutely don't want to take up too much of your time, but I hope that you contact me. I'm going to go to the end of my slides now and show you how you can reach me and how you can contact me. So don't watch the screen. It's going to go really fast all the way through. All the other stuff that we can talk about, maybe at a later time. So the best way to reach me is you can go to azclimate.asu.edu. You can ask me any questions. I'm happy to talk with you. Happy to come speak to your folks. If you have a class that you want me to speak at, I really enjoy doing that. I especially enjoy talking to elementary and middle school classes because I think those are fun. If you're a high schooler and you want to talk more about meteorology, come talk with me. I'm happy to do so. And of course, if you are someone that's always been interested in weather and you want to know more, I'm happy to talk with you as well. So thank you very much for your time. And I think we're going to end it there, if that's okay, Aubrey.
Thank you, Erin. That was great.